An algorithm is a finite sequence of well-defined step-by-step instructions to solve a given problem. For example, suppose I give you this instruction: download the syllabus from Blackboard. It might seem like a clear, well-defined instruction, but if I tell you this, I'm actually assuming you know a great deal about the world. I assume you know what Blackboard is and how to access it. I assume you understand what I mean by syllabus and which course I am referring to. An algorithm would look more like this. Open an internet browser. Place the cursor at the address bar. Type this address. Press enter. Type the username. Type the password. Click on login, and so on. You do follow this algorithm when you go to Blackboard, but I don't need to give you all these instructions because you know how to do this. A computer, however, needs detailed instructions like that because it doesn't have world knowledge and common sense. So we have to tell it exactly what to do, using types of instructions that it can perform. So what can a computer do? Well, it has access to its input devices like the keyboard, so it can read input and store it in memory. It can process data and perform simple arithmetic calculations like addition, subtraction, division, and multiplication. It can also perform logical operations to compare numbers, like less than, larger than, and so on. It also has access to output devices like the monitor, so it can produce outputs. And as you should know, at the hardware level, everything is in bits, zeros and ones. So machine language is in binary, and the code we will write in Java gets automatically converted to this format using a compiler. When you run a program, the code is stored in main memory, in machine language of course, and the central processing unit, or CPU, is where the instructions are fetched and executed one by one. These instructions are simple tasks like adding two numbers or comparing two numbers or moving numbers to and from the main memory. The main memory consists of memory cells that can store bytes of data, and each cell has a unique address. One possible instruction is to store a value in a memory location. For example, store 10 in location 3001. However, in actual programs, we do not explicitly use memory addresses. Instead, we use variables. A variable is a location in memory where you can store a value. We don't care where exactly in memory that location is. We just want a way to easily refer back to that location. So we pick convenient names that we can remember in a program. For example, I could pick X as my variable name. So instead of this tedious instruction, I could say store 10 in X. And the operating system will take care of finding an empty cell in memory and assign that value to it. So now whenever you want to use that value, you can just use the word X. The instruction used to store a value in memory is called assignment. And in most programming languages, we use the equal sign. The left-hand side is a variable name, and the right-hand side is the value. So we can say X equals 10. Keep in mind that this is not the equal sign that you are used to from math. You cannot say 10 equals X. This is not a valid instruction. The left-hand side has to be a memory location, and the right-hand side is the value that you want to store in that location. So we could have Y equals 30. Or we could have Z equals X plus 1. So again, the left-hand side is the memory address, so it could be here. And the right-hand side is the value. So this has to be evaluated to a number. X equals 10, so instead of X here we will have 10 plus 1, so the value for Z will be 11. Actually, whenever we have a mathematical operation like addition, what really happens, those values will be copied to the processor, which will add them up and produce a result. Now, when we use this assignment operation Z equals, we're saying store the result of X plus 1 in the memory location Z. So there are actually two instructions here. This addition operation, and then we have the assignment operation. Suppose we have these additional instructions. q equals y, q equals q plus 1. What do you think would be the value stored in q and y after all these instructions are executed? The first operation is an assignment instruction. So we have a new memory location, q, equals, the right-hand side has to be a value. So we have to evaluate what y is. Y is 30, so that value will be assigned in the memory location q. Now the next operation, q equals q plus 1, these values will be taken to the CPU for addition. So this is 30 plus 1, and the results will be 31. And then we have this assignment instruction, which will store the result 31 in the memory location q. Now q already exists in our program, so it's not a new memory location. It's the same one. The value will be overwritten to 31. Another possible instruction is to read from an input device, like the keyboard. But we still have to store the value that we read to a location in memory or a variable. So we could say, read a number and store it in x. Now, as I write this code, I don't know what the value of x is. Only when we run this program, the computer will wait for an input, and depending on which key was pressed on the keyboard, the value will be stored in x. But I can still use x in my program as a variable. So for example, I could have y equals 10. So this is another variable that I created. And q equals x plus y is another set of instructions. X plus y is the addition of the variables x and y. Again, I do not know what the result will be. This will depend on the user input. And the result of that operation will be stored in the location q. Suppose now this is my program. What is the operation that is implemented in this program? Let's take an example. Suppose the input x equals 3. Now q will be x plus y, so that's 3 plus 10, 13. And r is a new variable. R equals q over 2, so that's 13 over 2. And then we have another operation, r equals r plus x. So the current value of r is 6.5 plus x equals 3. So we have 6.5 plus 3. That is 9.5, and that result will be stored in the location r. If x equals 10, then the result of this program will be different. So x equals 10, q will be x plus y, that's 20, r will be q over 2, that's 20 over 2. And then we have r equals r plus x, so that's 10 plus 10, which equals 20. So when you have a program that reads user input, typically the output will depend on the input. You do not know what your program will produce until you actually run the program and give it some inputs. Also note that what I'm writing here is not actual code that you can run on a computer. This is called pseudocode. I'm writing instructions in English, but it would be easy to convert these instructions into any programming language, because I'm using simple instructions that I know computers can do. We can add a final instruction here, output R or display R, to indicate that we want the result to be sent to an output device like the monitor. Suppose we are given this description. Calculate the square root of a given number if it's positive. Otherwise, display an error message. We have to design our algorithm based on this description. We know the main objective is to calculate the square root. But the square root of what? Any given number. So clearly this has to be user input. But we also have this constraint that the number has to be positive. So far we haven't seen any way of doing that. Our pseudocode was just a sequence of instructions that are executed one after the other. What we need to do here is a way to branch, which is an instruction to go to a different part of the program based on a condition. And I mentioned before we have these logical operations like less than, larger than, equals, not equals, and so on. So we can use these to write conditions for branching. First of all, we need to read the input number. So the first instruction should be an input statement. We could also add an output statement first to request an input. In an actual program, you want to make your program interactive, because a person using your program will not know what they should do. So you have to tell them that they need to input a number. So I'm going to add this statement. Enter a positive number. And then I need to read that user input. So I'm going to have an input statement. Again, this is pseudocode, so I don't care how you are actually writing those instructions as long as they are clear. So sometimes I use the word input, sometimes I use the word read, sometimes I use output instead of display. It doesn't matter, right? So these are not actual instructions. These are just descriptions of the instructions that we could later implement using a programming language. Okay, so now that we have our input, now we need a way to branch depending on a certain condition. The condition that we want to check is that the user input x is positive. Okay, so given the logical operations that we have, we can use the larger than 0 as a condition, right? So we can say if x is larger than 0, then we want to perform certain operations. So I'm going to add those operations here as a we want to calculate the square root. So I assume that I have the operation square root, and I will store the result in the variable y. And then I'll display y as an output. Okay, but now we have another condition, is that if the value that was entered is not positive, so that condition we can write it as if x is less than or equal 0. So either it's negative or it equals 0, it means it's not positive. In that case, I want to output an error message. Okay, so these are called conditional statements, and these are the conditions, right? And these are logical statements, so they evaluate to either true or false. So suppose the input was the number 10, then x larger than 0 will be true. X less than or equal to 0 will be false. Okay, and whenever the condition is true, the statements in that branching instruction will be executed. So if the number is actually positive, so this will be true, and then these two statements will be executed. But if this was false, these will not be executed, and we will go to the next instruction, which is another branching instruction, and another condition is checked. If the number is less than or equal to 0, if that's true, then this statement will be executed. So now notice something here, that these two conditions are complementary, which means if this is true, for sure this will be false. And if this is false, for sure this will be true. We have a more convenient way of describing this. Instead of writing the complementary condition, we could just say, in English we say otherwise. That was in the description of the problem. Otherwise, display an error message. So if the number is not positive, then for sure it's either negative or 0. So we don't need to write explicitly that condition. We can just say otherwise, or we can say else. If then else is a common instruction in a lot of programming language. That's why I'm using it here. But again, this is pseudocode, so you can use whatever language you find convenient.